Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. So as the continuation of the lecture series in the topic design of experiments, here in this video we are going to discuss about Latin square method, which is an advanced method in ANOVA, that is analysis of variance. So Latin square is an advanced experimental design. So it is used when two news in factors are affecting the experiment. So what we are going to see in this video are what are the concepts of LSD, layout structure, advantages, applications, limitations, and assessment questions. So first let us recall what we have seen in the previous video. So in CRB there will be no Newisan factor, that is it is purely a simplest model without any disturbances. So when it comes to RPD there will be one Newisan factor which is controlled using blocks. When the thing or data is also heterogeneous, we'll move into RBD. So with heterogeneous data, when two Newisan factors are present, we'll go deal with the Latin square method. So here is an example in which we can use this. So when soil fertility varies along row wise and column wise, that is factors like soil fertility and the fertilizer affects the yield. There are two Newisan factors, then we can use this Latin square design method. So here is an empathy in which we are going to imagine a scenario that again an agriculturalist scenario. So the fertility changes from the right to left and the moisture changes from the top to bottom. Then there are two Newisan factors. So if only one source of variation is controlled, experimental error still remains high. So researchers must arrange this in a order that every treatment appears exactly once and every treatment appears exactly once in column and in rows. So this arrangement will reduce variability effectively. So next is a defined part. So Latin square design is an experimental design which is used to control variability in two directions simultaneously. So here the structure are number of rows will be equal to number of columns. So as Sudoku is one of the application of Latin square, that is so we'll be having 3 by 3 rows, 4 by 4 rows or 5 by 5 rows. So each treatment appears only once in every column and row. So here are the assumptions. So no interaction among treatment, row and columns. So the variances will be equal and the treatments are independent of errors. So here is an ideate in which the procedure is described. That is first we have to identify what are all the two Newisan factors in the data. Next we have to arrange the treatment in a square form, that is Latin square design, either in 3 by 3, 4 by 4 depending on the problem. Next, we have to make sure or ensure each treatment appears only once per row as well as in the column. Next, we have to randomize rows, columns and treatments. Next is we have to analyze using three-way ANOVA without interaction. So next is a simple example, or let's consider 4 rows in 4 columns. So each fertilizer appears only once in each row and column. So this balances the experiment very much effectively. So next is in application part, in which where all we can apply this. So in agricultural researches, medical industries and educational sectors and any stakeholder engagements and all, we can use this. Next is an advantage. So the control two Newisan factors. So high precision reduces experimental error significantly. So if there is an advantage, there will be a limitations also. So this cannot be used when the arrangements in the experiment are very much complex. The number of treatments must be equal to number of rows and columns. So if this varies, then we cannot apply this method. So here is a mind map in which what we have we are going to see what we have discussed in this video. First we have studied about the previous RBD method, then we moved into the empathy part. So why we have to use this Latin. Then what is Latin? Next, how we can apply this Latin and how to proceed with this we have seen, and we have seen the applications and where this can be applied in real life we have seen. Yes, the next is assessment question. So LSD is analyzed using three-way method without interaction. Next, the source of variation in LSD are rows, columns, treatments, and error. So the LSD requires the assumption that block effects are interaction effects are absent. So here are the references, and thank you.